Today we're going to introduce the computer science part of the course. Up until now, we've primarily been doing web design types of things. We've learned how to use HTML to represent the content and CSS to present that content and make it pretty and lay it out in the right way. But now we're actually going to start talking about programming. And so we're going to do some of the really fun topics of the course. Let's switch quickly to two-box mode. There we are. So earlier in the course, we learned an important computer science principle. And that principle was that we should separate content from presentation. And really, this is part of a much broader principle that says we should separate content and presentation and control from each other. What is control? Well, in computer science, when we talk about control, we mean the control flow of a program. In other words, it's the sequence of steps that the program executes. So usually a program executes linearly. We say, do this step, do this step, do this step, do this step. But sometimes we might say, OK, now go back and do this step, and then this step, and repeat over and over. Or we might say, OK, if this condition is true, go on. But if it's false, jump over here and do this other set of steps. We call that the control of the program, or the control flow of the program. So we should separate the parts of the program that are involved with control from the parts that are involved with data and the presentation of the data. This is sometimes expressed in terms of the model, view, and controller concept. We want to store data in a model. That's how we're going to store our data. And maybe that model is a file or a database. We also worry about the view. What does the data look like? And how do we present the data? And then the controller is where we have our code that puts the two together. So we're going to stick to that separation of concerns. We're going to have HTML for our content, CSS for our presentation, and for our control, we're going to use a programming language called JavaScript. JavaScript is actually not the only game in town anymore. It used to be that if you wanted to control a web page, you had to use JavaScript. But recently, a new programming language is becoming popular. It's called WebAssembly. Google is pushing it really hard. The idea is that instead of programming in JavaScript, you're going to write your program in a high-level language like C or C++ or maybe even Java. And then you're going to compile your code into this underlying representation called WebAssembly that every web browser understands. And WebAssembly will do all the same things that JavaScript does for us now, but it'll have some performance advantages because WebAssembly can, in theory, run faster than JavaScript does. At any rate, most browsers today don't support WebAssembly yet unless you put them in some sort of experimental mode, and we're going to focus on JavaScript. But the good news is that if you learn JavaScript, it's very easy to pick up WebAssembly. At least for the foreseeable future, a lot of the design of WebAssembly is based on what we already do with JavaScript. So there's a lot of similarities, and if you learn JavaScript, it should be pretty easy in 5 or 10 years when WebAssembly is the new thing to switch to WebAssembly. So when we talk about control, there are two kinds of scripts that we talk about. First of all, there are client-side scripts. Client-side scripts run in the client, that is, the web browser. And the purpose of the client-side script is to make the web page itself more interactive. So they allow us to respond to user input. For example, the web browser knows whether the user has clicked a button. The web browser knows whether the user has pushed a key. The web browser knows whether it has received data from the server, some kind of notification that somebody's posted something. And so we can run a script in the web browser that checks for these conditions and responds to them. On the other hand, we can also write server-side scripts. Server-side scripts run on the web server. And the advantage of that is that they can store persistent data that's shared between sessions. So if I log into my account from one web browser and do something, the server can remember it so that if I log in from another client, another web browser, that data is still there. So for example, if I upload images to a web gallery, I don't want them to only show up in the browser that uploaded them. I want them to be on the server so that I can see them from any computer that I log in from. This also means that server-side scripts allow us to communicate with other users. If I post something and it's stored on the server, other people who connect can see it too. So we're going to learn both client-side scripting and server-side scripting. And most of our client-side scripting will be done in JavaScript, and so that's what we're going to focus on today. So once you've written a file in JavaScript, you need to be able to pull it into your web page, and you do that with a script tag. So here's an example. I can say script, and then I can have some JavaScript code. In this case, it pulls up a message box that says hello world. and then I have a slash script tag that says the script is over. If I embed this in a page and I load the page, when the page loads, it'll run this script, and it'll pull up a dialog box that says hello world. This is really not the best way to do things. It's great for testing and debugging and for real short prototypes and things. But in a production system, we want to separate content from presentation from control. And so to do that, we want to put our control, our JavaScript files, into a separate place, a separate file on the server. So we can do that by creating a file that has the JavaScript code in it, the alert hello world, and then pulling it in with a script tag that has a source attribute. So here at the bottom of the page, of the slide, I have a script tag, and it's just like the other script tag, except that instead of having the code between script and slash script, I've put a source attribute in, src, and I've set it equal to a file name, script.js. And what this will do is load script.js from the server and run the code that's in it. Now, typically, I don't want to just run the code right away as the page is loading. Instead, I either want to wait until the page is finished loading, or I want to respond to some event. Maybe the user clicked a button, or they pressed a key, or they moved the mouse over my link, or over a paragraph, or over some sort of object on the page. If I've got a drawing program, for instance, maybe they moved it over a circle, and then they clicked and dragged it. Maybe it's the page is finished loading. Maybe an element is changed. Maybe I clicked something, and that caused the size of an element to change. And now I need to run some code to update the element so that it fits properly on the page now. Also, things can go wrong. An error can occur. So I need to be able to respond to that. I need to be able to have some way to detect errors and handle them. So that's an event that could occur. So how do I do this? Well, first of all, I create a function in JavaScript. And this is an example of what a function looks like. This is a function called pageLoaded. And all it does is print a message that says, welcome to my page. And then, in my HTML, I add an attribute to one of my elements. In this case, I'm going to add an attribute to the body element. And the attribute is called onLoad. Excuse me. OnLoad is a special attribute called an event attribute. An event attribute maps a function in JavaScript to some event that can occur. So in this case, when the page has finished loading, it's going to run this JavaScript code. And the JavaScript code that I've written calls the pageLoaded function. Excuse me. So if I were to put that into a web page and pull it up, it would look like this. The page would load, and as soon as it's done loading, it's going to pull up the welcome to my page message. So if I want to be able to do that, I need to know how to make a function. And JavaScript functions all look like this. They start with a keyword function, and that's followed by a name. And that name can be anything, but it has to be unique. Actually, I say it can be anything, but it has to contain only letters, numbers, and a few symbols like the underscore. I can't just have a bunch of random symbols for my function name. So I have function, the name of my function, like pageLoaded. And then I have parentheses. Parentheses are the symbol that identify a function. Whenever you see parentheses, you should think function. So I can tell whether something's a function because it'll have a name followed by parentheses. Inside those parentheses, I can optionally put some arguments. Those are inputs to the function. Maybe I want the function to behave one way if the user's name is Bob, but a different way if the user's name is Jeff. Well, then I need some way to know what the user's name is. So the user's name could be an argument to my function. And I can have as many arguments as I want. I can have no arguments, just empty parentheses. I can have one argument. Or I could have 2 or 3 arguments, and I just put commas in between them and give them all names. And then when I'm done with that, I have 2 curly braces, and those denote the beginning and the end of the code for the function. And inside those curly braces, I have a bunch of statements. And those statements can either go on separate lines, or they can be separated by semicolons. It's considered better style to put each statement on its own line, each one on a separate line. But it's not necessary. You can put 2 statements on the same line as long as you put a semicolon in between them. So for example, my pageLoaded function starts with a keyword function, and then the name of the function is page_loaded. My argument list is just empty parentheses because I'm going to do the same thing every time I run it. So there's no other input information that I need. No matter what, I'm going to do the same thing. And between my curly braces, I just have one statement. It's a statement that calls another function, a function named alert, and draws the text, "Welcome to my page," on the screen. So we can bind functions to events, and there's lots of different events that we can use. I already showed you the onLoad attribute that lets you bind a function to the event that the page has finished loading. You can actually bind a function to the onLoad attribute of other elements, and when that particular element has finished loading, it will trigger the function. You can also trigger a function to be called when an element has changed. The onChange attribute will bind a function to the change event. So for example, if I have a box that I've drawn on the screen, and I resize it, the onChange event will be triggered, and it'll call the function. Another attribute I can set is onClick. If the user clicks on the element, the function will be triggered. OnMouseEnter will trigger the function when the user puts the mouse over the element. So for example, if I have a link and the user puts a mouse over the link, the OnMouseEnter event will be triggered. There's also an event called onMouseOver. It behaves very similarly to onMouseEnter. The difference is that if I have an element inside another element, there's a distinction. For example, if I have a paragraph, and inside my paragraph I have a link, when I put the mouse over the link, onMouseEnter will be triggered in both the link and the paragraph the link is in. But onMouseOver will only be triggered on the link. Even though the link is inside the paragraph, onMouseOver won't be triggered in the paragraph. When I move the mouse away from an element, onMouseLeave is triggered, and it's similar to onMouseEnter in that it triggers it in all of the elements. So for now, we're mostly going to use onClick just because it's simple and straightforward, and it's easy to test. You click, and things happen. So one of the most important parts of any programming language is called I/O, input and output. We've already talked about input because input in JavaScript takes the form of these events that can happen. The user clicks on something. The user pushes a key. But there are also ways to produce output in JavaScript. And we're primarily going to use two of them, but I want to mention a few others as well. We already saw the alert function, and I'll talk more about that in a minute. Another way to produce output is to use the console.log function. We can also write to the HTML page itself with document.write, or manipulate the HTML of a particular element on the page by using the inner HTML property. And of course, we can also manipulate the web page directly. We can move things around. We can resize things in the CSS. We can add paragraphs and remove links. This is called manipulating the document object model. We'll talk more about that in another lecture. So first of all, a little bit more about the alert function. The alert function pops up a dialog box that contains a message. For example, if I have my script tags, I can put the function alert, and inside my parentheses, put the string goodbye universe. And it turns out the alert function is actually a method of a class. We'll talk more about objects and classes later, but it's a method of the window class. And so you can write window.alert and put goodbye universe in there to pop up an alert message in a particular window. If you leave off the window dot, it will still work. It'll just use the current window, which is typically what you want anyway. So that would look like this. Goodbye universe, and you have to click OK to get rid of it. Alert boxes are actually pretty annoying. People don't like pop-up windows because they hide the page and they make it hard to interact with the things that are behind them. You can't easily move them around often, and so it's not considered a good thing to use alert boxes in a production website. But it's really easy to use alert boxes in your code. So for testing and developing your page, alert boxes are great. And we're going to use them all the time as we get to learn JavaScript. But when you're writing an actual web page for a project or in the real world, you're not going to use alert boxes to communicate with the user. So what you actually might do if you have debugging information that you want to display, but you don't want the user to see it, you're going to use console.log. The console.log function writes to a hidden error console in the browser. So for example, I could call the function console.log, and in my parentheses, I could have the string 4score7. Notice I put double quotes around it because it's a string. We'll talk about why I do that in a minute. If I do that, Firefox and also Chrome, and I believe other browsers as well, have a browser console window that you can pull up In Firefox and Chrome, you push Control-Shift-J, and it'll pop up this window. In Chrome, it actually pulls up a little sidebar. It's a window, but it's embedded in the same pane as your web page. In Firefox, it's actually a separate window that you can move around independently. And they look a little bit different, but they have the same functionality. And what happens is that anything that you send to console.log will be printed in this window. But so will lots of other error messages. Error messages about the network connection. Error messages about the CSS and syntax errors in the CSS. And errors in JavaScript on your page, but also on other pages that you're browsing to from other tabs. Security messages, other kinds of logging. So there's a lot of information in this window. Now, I recommend that you reduce the amount of information there so that you can actually see your error messages. And in Firefox, the way to do this is just to click on the words net and CSS and security up at the top. You'll notice that there's little tabs up there. If you click on them, they'll turn white, which indicates that they're disabled. I would leave the JS or JavaScript tab blue, because that's where your console.log messages are going to come from. If you're debugging your CSS, pulling this up can be helpful. Turn back on the CSS tab. There are also some other ways to communicate with the user. One way is to use the document.write method. Document.write adds HTML code directly into the current web page, into the current document. During the loading of the page, if you have a script tag embedded in the page, as it encounters the script tag, it'll run the JavaScript, and anything that you document.write will be just added to the web page as if you just typed it in. So for example, if I document.write some link, href equals my link, blah, 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 /a. It's going to put that link right in the page where it ran the script. Unfortunately, once the page is finished loading, the web browser closes the document. And if you do a document.write call after the document has been closed, it reopens the document, and the process of reopening the document clears it. It deletes everything in the page. So it'll replace your entire web page with whatever you wrote. May or may not be what you wanted. So document.write is great for writing to new windows. If you use window.open to open a new tab, you can then use window.document.write to put content into it. But it's not so great for writing to the current document, because it probably doesn't do what you want it to do. So here's an example, document.write, your text is gone. So use it, but use it carefully. You can also make more fine-grained changes by changing the inner HTML property. We're going to come back to that one. Suppose I have a paragraph, and it says, walk the dog. I could actually find that paragraph using some code we haven't talked about and get a variable that points to that paragraph. And then I could use that variable to change the inner HTML property to walk the cat. And that would actually change the paragraph in the web page from walk the dog to walk the cat. So we've talked a little bit about control, but there are actually two parts to a program. There's control and there is data. And data is usually stored using variables. And most of you, I understand, have some programming background. You've had AP Computer Science or some programming course, probably in Java. And so this is going to be pretty familiar to you. But just to review, a variable is just a named memory location. Computers have memory chips that store information. They store numbers, they store images and color, and they store text. And all this information is stored in memory. But in order to access it, we need to know where in memory it's stored. We need to know its memory address. But addresses, numbers, aren't really comfortable for human beings. We don't want to have to remember that, oh yeah, the name of this person in my address book is at memory address 376. So instead, we give memory locations names, and we call those names variables. So for example, I might say, last name is Bob. And the computer will remember that last name is stored at memory address 376. Actually, Bob is a first name, not a last name. I guess Bob could be a last name. George Bob? It works. OK. A big difference between JavaScript and many other languages is that JavaScript is weakly typed. It's similar to Python in this respect. It's a weakly typed language. What does that mean? Well, what that means is that when you make a variable in JavaScript, that variable can be any type, and its type can change. So in other programming languages like Java or C, I have to declare my variables. I have to say this is an integer variable, and it can only hold integers. It can be 7 or it can be 10. But once I make an integer variable, I can't set it to be George. Doesn't work. It has to stay an integer for the rest of its life. Well, in JavaScript, that's not the case. In JavaScript, I can set x to be 7, and then later say, I don't want it to be a number anymore. X is Fred. And I can set x to be a string, the string Fred. So variables can change from one type to another in JavaScript, just as they do in Python and other weakly typed languages. This is nice. It makes them easier to use because we don't have to worry about the type as much. But it can lead to some kind of confusing programming errors if we're not careful. So to create a variable, you just use it. So for example, I could say I gets 0. Gets is how I pronounce the equal sign. I gets assigned the value 0. So in other words, I'm going to put 0 into I. Or as I have here in this example, I could say I gets 10 and put the number 10 into I. And the computer will remember that I is 10. So if I print it back out by saying alert, that's how I print a dialog box. And inside I say the variable I is set to plus I. It'll actually pull up a dialog box that looks like this. The variable I is set to 10. It remembered that I set I to 10. So even though you don't have to declare a type for your variable, you do have to initialize it. You have to set it to some initial value. So I could say value gets 0, or I could say var cost gets 45.7. Var is a special keyword in JavaScript. The name of the variable isn't var cost. The name of the variable is just cost. I'm setting cost to be 45.7. The var in front of cost makes it a local variable. And basically what that means is that it is hidden from other functions. So if I make this variable var cost in a function, I can only use it in that function. If I try to access it from another function, it's going to make a different variable named cost that's not the same. If I change one, it won't affect the other. If that's too technical for you, don't worry about it. For now, most of the time we're going to put var in front of our variable names. If you get in the habit of doing that, you'll probably be safe from a lot of programming mistakes. So even though JavaScript is weakly typed, it does have types. It just figures out what they are for you. And there are very few types in JavaScript. There are actually, I think, just these 6. You can have numbers. And numbers are always floating point numbers. That means that they can have fractions and decimals and exponents. So for example, 3.7 is a number. So is 12. So is -2. So is 5 times 10 to the 9th. Variables can also be strings. Strings hold text. So for example, elephant. The word elephant is a string. I can have Boolean values. Boolean values are values that can be either true or false. So if I compare two things and say, are these the same? I'll either get back, yes, they are, or no, they aren't. That value, that result, is a Boolean result, a Boolean value. I can have objects in JavaScript. Objects are going to represent the web page and the different elements inside that page. They're also going to represent the HTTP request and the HTTP response that go to the server and come back, and many other things. Objects are a way that we can put a lot of different pieces of data together into one unit. We're going to learn a lot more about objects, but not today. There are also 2 special types. Null, excuse me, the null type is like an object. It's treated like an object, and it means that there is no value for this variable. Undefined is similar, but subtly different. Undefined means there has never been a value for this variable. So if I set x to 10 and then I set it to null, if I try to do something with x, the compiler, sorry, not the compiler, the browser will know that x has no value. But that's different from it never having had a value, which is undefined. Subtle, weird. It has weird semantics. If you try to compare a null value to an undefined value, they're not equal. It's bizarre. Don't worry about it. If it's too technical, that's OK. You don't need to worry about this until you do need to worry about it, which probably will not happen in this course. But I want you to be aware of this difference. If your program has weird behavior when you're comparing things, it might be because of this difference between null and undefined. And so this will give you a hint to ask me about whether your comparison is the problem. So there are different kinds of numbers. I said all numbers are reals. They're all floating point numbers. And that's true. But that doesn't mean we can't store integers in a number. So if I have an integer like 3 or -10, I can store that in a number. But I can also store other things like 3.45 and negative 2.34. There are also two special numbers that I can store. If I write the word infinity with a capital I, that's a special number that JavaScript knows is the largest number it can store. Similarly, negative infinity is the smallest number it can store. So you can set a variable equal to infinity or negative infinity in JavaScript, and it'll do the right things when it compares it with other numbers. There's also a value called not a number. This is what you get if you, for instance, divide by 0. It doesn't know what to do when you try to divide by 0, so it sets the result to be NaN, which stands for not a number. Just as I have numbers in JavaScript, I also have strings. String constants in JavaScript have to be in quotes. The reason we need quotes is so that it can tell whether I'm using a variable name or a string constant. If it has quotes, it treats it like a string constant, and it'll print out the literal text between the quotes. If I don't have quotes, then it thinks it's a variable, and it tries to find what value it has and print that. So you can actually use two different kinds of quotes in JavaScript. You can use single quotes, or you can use double quotes. Either one will work. So I can say alert single quote my message, or alert double quote second message, and both of these will print. If I need to actually print a quote mark inside my message, I can do that using escape sequences. All I have to do is put a backslash in front of it. And the backslash says, OK, don't end the string here. Instead, put an actual quote mark in. So if I say backslash double quote, that'll give me one double quote mark. It won't print the backslash. Backslash single quote will give me an actual single quote. Backslash backslash is what I have to do to get a real backslash. That'll just give me one backslash, not two. Backslash T will put a tab character in, and backslash N will go to the next line. That doesn't really have a lot of meaning in JavaScript usually, because on the web page we ignore the new lines, right? If we want to go to the next line on a web page, we have to put a line break in with BR. So BR is different than backslash N. Backslash N will put a new line into the document source code. So it makes it easier to read when you view source, but otherwise it doesn't affect the web page very much. So for example, I could create a variable called name and set it equal to single quote Robert's string. But notice, because I use single quotes on the outside, to get the apostrophe between T and S, I have to put a backslash in front of the single quote, or it'll think that the string is just Robert and ends at the apostrophe. If I put the backslash in, that won't happen. It'll actually put a single tick in. We can also get the length of a string by putting the words .length at the end. So for example, I could pull up an alert box with name.length, and it'll actually count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 characters in Robert's string. So it'll bring up a message that says 15. Similarly, I can do the .length on string constants. So I can say 1, 2, 3, 4, 5 in double quotes, .length. And when I pull that up in my alert box, it'll say it's length 5. I can do things with my variables just like I can in other languages. I can assign values to them. So I can set num to 20 or set name to Bob. I can do arithmetic on my numbers. And the usual order of operations applies. So here I can set val to be 5 plus num times 3 mod 4. What does that mean? Well, num is 20, right? So I do multiplication first. 20 times 3 is 60. 5 plus 60 is 65. %4 means to take the mod with base 4. Mod is like a remainder. So I divide by 4 and take the remainder. So 65 divided by 4, I think, has a remainder of 1. So this will set val to 1. I can also do subtraction and division. So 1 minus 1 is 0. Divided by 2 is still 0. I can also increment variables. Plus plus val or val plus plus, either one will work. We'll add 1 to val. So if val was 3, now it's 4. Minus minus val will subtract 1 from val. So if it was 6, now it's 5. Val plus equal 3, we'll add 3 to val. So if val was 7 and I plus equal 3, it'll become 10. I can also do minus equals, times equals, divide equals, and percent equals to do the other operations. I also have operations on strings. In particular, I can concatenate them. Concatenating means to add to the end. So here I can take name, which is Bob, and add Steele. And that will make a new string, Bob Steele. And I can put that back in name. I can compare two variables. JavaScript has a bunch of comparison operators. To compare strings for equality, I can use equal equal. To compare strings for inequality, I can use bang equals or not equal. I can also do greater than or equal to, less than or equal to. But I also have these two strange operators. I have equal, 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 and bang equal, equal. The difference between equal, equal, and three equal signs is that equal, equal, and bang equal, the comparison operators with just two symbols, do value comparison. So if I compare the number 3 with the number 3, of course they're equal, so I get true. But if I compare the number 3 with the string 3, as long as I'm using equal, equal, I will still get true, because the values are true. It takes the string, compares it to the number as numbers, and if the value of the string is the same as the number, it's true. So the string 3 and the number 3 are equal if I use equal, equal. However, if I use equal, 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 three equal signs, while the number 3 is still the same as the number 3, the number 3 is not the same as the string 3. So we say equal, equal, and bang equal do value comparison, but three equal signs and bang equal, equal, they do value and type comparison. So if the types aren't the same, it's not equal. Using those comparison operators, I can have control statements like if, for, and while loop. These are pretty much the same as in other programming languages. So for example, I can have an if statement that checks if name is the same as Bob. And if it is, it brings up an alert message that says, hello, Bob. Notice the parts of the if statement. I have the keyword if. In parentheses, and the parentheses are required, I have some comparison, some condition. Then I have curly braces, and between the curly braces, I have my code. I can also have loops. So in Java, you probably learned about for loops. So I can say for, and then in parentheses, I have to have three things. The first thing is an initialization. I have a counter variable, and I set it equal to 0 typically. You can think of my variable I as being the number of times I've gone through the loop. So at the beginning, I haven't gone through it any times. I set I to 0. The second part of the for loop is a comparison. It tells me when to keep looping. So as long as I is less than 3, I'm going to keep looping. In other words, as long as I haven't done the loop 3 times, I want to keep looping. Finally, I have an increment that tells it what to do each time I go through the loop. And in this case, I want to add 1 to I to keep track of the fact that I've gone through the loop one more time. So I start at 0, and while I haven't gone through the loop 3 times, I increment. In other words, I'm going to loop exactly 3 times. And each time I'm going to print the value is, and I'm going to print the value of I. So I'll print 0, 1, and then 2, and then I'll stop. I can also use while loops. Here's an example where I've created a string, and I've set it to empty to double quote, double quote. When you have two double quotes right next to each other, I know it's really hard to read on the screen, but that's called the empty string, and it's a really important value. What I'm going to do is I'm going to start with the empty string, and I'm going to loop until the length of my string grows to size 10. And each time I'm going to tack a star onto the end. So initially it's empty, then I'm going to put 1 star in, then I'm going to append another star, concatenate another star, concatenate another star, until I get to a string that's 10 stars long. When the length is 10, then I will stop, and I'll pull up that big, long string of stars in an alert box. So I should point out that JavaScript also supports more complex conditions, compound conditions, with and, or, and not. And is ampersand, ampersand, that's shift 7 on your keyboard. Not is bang, shift 1 on your keyboard. And or is 2 vertical bars, or what we call pipes. And those 2 pipes represent or. You can get a pipe by holding down shift and pushing the backslash key on your keyboard. That's the slash that's above the enter key. JavaScript also provides objects. You can create your own, but there's also some predefined ones. In particular, there's an object called window. And we're not going to do a lot with window, but it provides 2 important functions. If you call window.open, it'll open a new window or a new tab. And we can actually then control that window from our script. You can also close the window by calling window.close. By default, if you just say window, it'll control the current window. But window.open actually returns an object that you can store in a variable. And you could maybe name it new window. You could say var new window gets window.open. And then you can do things to new window. You can change its text or close it. And that can be really useful. There's also an object called document. That's actually an object inside the window object. It's a part of the window object. So you can also say window.document. But JavaScript, for convenience, will allow us to omit window dot. If we just say document, it'll look at the current window and get that document object. So, for example, we can use this to get the URL. We can say document.url, and that'll fetch a string representing the current location in the location bar. We can also get the body of the web page by saying document.body, and this gives us an object representing all of the HTML in the current page. So, for example, I could use this to delete the page and replace it with the text "Hello World" by doing document.body.innerHTML and assigning it the string "Hello World." So, in summary, JavaScript is a programming language that allows us to make web pages interactive. We can trigger JavaScript functions in several different ways. 3 of the important attributes that we can use are onLoad, onClick, and onMouseOver. It's a weakly typed language, which means that variables can change types and that we don't have to declare their type. And we have lots of different kinds of variables. We have numbers, strings, booleans, and objects. We'll talk more about JavaScript next time.